the last session prior to the lunch. And so I'm happy to introduce Nick Moore. He's a contributor of MicroPython ESP32, and that's his talk today. Welcome, Nick. And over to you. Oh, sorry.
Thanks, everyone. This is indeed the coveted just before lunch slot. So if any of you feel yourself kind of slowly slumping over, I won't take it personally. It's the way these things go. So I'm here to talk about the ESP32 port of MicroPython. We've talked about MicroPython as a project overall from Damien. Talked about some specific application of MicroPython as a great way to prototype stuff from Anna. And I'm kind of talking about this ESP32 port, which I'm really, really excited about. So it's great to be able to come and talk about it to you. There's some background about MicroPython, but it's probably not all that necessary since we've already kind of covered that fairly well. But for anyone who wasn't here before, it's a re-implementation of Python. I'd say it's a Python because it's very much like all the other Pythons. And if you know how to program Python, you know how to program MicroPython. It runs on small controller boards of various kinds, including the Pi board and the microbit, and these ESP3266 systems on a chip that have become very popular recently, and now it's got a port to the ESP32. What are those chips? An ESP8266, which you can't really see because it's all pretty horrible, is a small system on a chip featuring onboard Wi-Fi and various other peripherals. They kind of first, actually before I get onto that, they're made by a company called Espressif, who are a fabulous manufacturer. I think the thing that makes Espressif particularly interesting is they're one of the first of the Chinese manufacturers to really embrace the open source world. They're very active in an open source community. They're very supportive of our open source development efforts. And that's really great. And I think that's been a great advantage for them as well. The 8266 became a real enthusiast stream, partly because it's very powerful for what it is, partly because you could get them for like $2. And the company's learned a lot out of that. They've taken a lot of inspiration from the things people have done with 8266s, many of them fairly silly, but nonetheless, people have had a lot of fun with them. People have tried a lot of things. People have put a lot of interesting stuff together. And the company's been able to learn from that and combine a lot of that knowledge into the ESP32. So, as I mentioned before, the 8266 came to prominence as a Wi-Fi accessory almost for Arduinos and things like that, until somebody looking at the spec sheets realized it was, well, several times as powerful as the Arduino it was helping out, and that this relationship seemed a little silly, and that perhaps we should just develop directly for the 8266 instead. It's got a reasonably nice C-based SDK. It's not that hard to get started in, but there is a bit of a barrier to entry there. And thankfully, someone, Damien, ported MicroPython across to it. I discovered this, I just started developing some stuff for 8266. I got really fired up about it after LinuxConf Geelong, I think it was. Got really excited about this whole 8266 chip and writing C again, and I hadn't written C in ages. And just as the novelty and excitement of writing C again was starting to wear off, MicroPython came out. So I leapt upon MicroPython and went, this is the coolest thing ever. And I got more into it, and I got more into it. I got really excited about it. And then I started working on it instead of just with it. And then I started writing C again to work. And so the cycle continues, but never mind. So following up on the 8266, there's now the ESP32. As I said before, it's taken a lot of inspiration from what people have done. It's more powerful again. There's 2 CPU cores instead of 1 CPU core. There's an ultra low power processor, which is a really cool little accessory that's really just like a very small, very slow CPU that's just got enough power to wake up the other CPUs if something interesting is happening. And if you're running on a battery, that's a really important thing. Runs at a slightly faster clock rate. Most importantly to us, it's got a heap more RAM. 520K does not sound like a great amount of RAM to a modern developer. I installed some software yesterday to do the machine learning thing that downloaded, I don't know, half a terabyte or something of data onto my laptop just to install. But it's enough to be usable for Python, for MicroPython. The 160K headroom on the 8266 is plenty enough to run MicroPython, but your applications tend to bump into that limit fairly easily. The 520K gives us a bit of breathing room. It's also got a bigger flash, which is really nice. These devices are much less powerful than something like an RPi-0W, which is the next sort of thing up that you might be thinking of. That's the wireless RPi-0. That's a much more powerful CPU running at a faster rate. It's got a lot more memory. It's got a lot more ability to expand with flash and things like that. But these provide a little middle ground. It's an interesting market segment that's kind of opened up between the 8-bit sort of Arduino AVR world and that RPi world. The 32 is very interesting because it features, as well as the Wi-Fi that you know about, it's got Bluetooth, which is really handy. A lot of things these days speak BLE of various kinds. It's great for talking to mobile devices and other sensors and things like that. It's got more I/O lines than the 8266, which is really handy. It's got more than one analog input. As Anna mentioned, there's only one analog input on the 8266, which can get a little bit annoying at times. The ESP32, you can configure like 8 of them, and you can actually change them between pins, which is kind of cool. It's also got a digital to analog converter, which is kind of handy. Pulse width modulation on various pins. They've done a really interesting thing. They've built a capacitive touch sensing circuit into the thing, and so there's 8 capacitive touch sensors. So if your project wants to have a touch interface rather than a button interface, it's really easy. You don't need any external components, just a piece of copper, which is a really good feature. It's a really interesting, it tells you something really interesting about their approach. This may not be the cheapest system on a chip out there, but if you need no other chips on the board, they can still compete. So it's a really interesting little way of thinking about it. And similarly, there's that ultra-low power processor, and there's even things like there's a Hall effect sensor built into the chip. I think that's pretty cool. Very few people need it. However, it's there, it's easy to make. It's just another piece of silicon on the die. If your application does, for some reason, need a high current measurement device, you can just lay your board out so that the processor has the power line running right past it, and you'll see a signal on that Hall effect sensor. Well, that's kind of cool. One less component, again. A group of Russians called Zeptobars are very good at boiling chips in acid and taking photos of them under a microscope. So this is actually a picture of a decapped ESP32. It gives you some idea of just how crazy the architecture of these chips is. If you zoom in on that top corner there, you can actually see the circuitry of this thing, the coils and the stuff to make a hardware radio. I think that's quite fascinating that you can actually do this. You can make coils and wiring and circuits out of silicon that are right there on the die. And it's actually quite beautiful in a strange and, I don't know, it reminds me of maps in those old games like Quake and things like that, with the circles and paths and all of that sort of stuff. It's really amazing that this is a thing we can do these days, I think. You normally wouldn't buy it as a individual discrete little piece of silicon because frankly the pins are far too small and you can't even see them. But they're available as these sort of modules which are much easier to solder. They're on a 20th inch sort of pitch around the edge, so you can actually hand solder them if you work at it. And they're quite a handy little chip. They've got a little RF screen. The tab on the top there is a built-in antenna, so you don't even need to deal with anything that isn't like a digital 3.3 volt line. Oh, sorry. And the flash memory is under that little can as well. So it's all basically there for you to use. It's quite easy to work with that kind of thing. If that seems also a little bit too hard to deal with in terms of soldering, there are lots of these boards available from various manufacturers. There's a SparkFun one there in the middle, which has got an integrated battery controller. The other one, there's Adafruit. Oh, sorry, that one's a dev kit C. The other one is an Adafruit Feather. I should know that. Does it say it in tiny little letters? No, it doesn't. One of their Hazard range maybe or something. It's got an onboard battery controller as well. The battery controllers, as Anna said, are very, very handy if you want to have some kind of portable device because it's something that's quite easy to get wrong. So having a board that has that on there so you can just plug a LiPo in is really handy. So they're really good, and those are standard headers around the outside. Makes it very easy to get started on this stuff and prototype stuff together with little wires. All right, so that's the module. I want to just talk about community, since we're here. One of the things about conferences is they're very much about the community and about having a community. I think it's really important that we have a MicroPython community, that we have a Python community and a MicroPython community within that, and an ESP32 MicroPython community within the MicroPython community. I noticed this news article the other day. Intel launched with great fuss and excitement the Galileo platform and all of this sort of stuff, and it was going to take over the world of IoT, and everything is going to be fantastic, and lots of people have them, and it's all going to be beautiful. And there was no real community behind it. And so whatever it was, a year later, when it hadn't really taken off and everyone's looking at their watch going, oh, did we do anything cool with that? No, not really did anything cool. They just shelved it, just like that, bang. So anyone who spent a lot of time and effort and stuff developing stuff or learning about that platform, it's kind of evaporated from under you, which I think is really disappointing. I mean, it was a nice platform. It was a good idea, but unless there's a community, a single company can't push a platform along. Well, they can for a while until they lose enthusiasm. They can't make it a global thing. So it needs to be more than that. It needs to be a community of people. And that's something I'm really trying to get going with MicroPython as well. So where are we at with MicroPython? So I talked here last year, possibly this very room, about ESP8266 MicroPython. And that was a lot of fun. And at the time there was like much muttering about this new ESP32. Those modules actually finally started making it out onto the market in about November. And then they promptly disappeared off the market again as every single one of them sold. And then they appeared again here and there in dribs and drabs, and everyone responded to this in the sensible way by ordering as many of them as they could possibly get hold of, and then they immediately went out of stock again. And finally I got hold of my first ones in November, and we could start working on stuff. Damien got hold of his as well, apparently, around then, because the initial port dates back to December, which is when the REPL started to actually work. I can't actually remember. I'm not very good with dates and times, but I am pretty good at typing git log into the terminal. So around December somewhere there. And then I ended up coming across and doing some work on the project with Damien to get the Wi-Fi stuff going and TCP sockets and some more support for other GPIO functions and that. And that work, that initial work on this port, I'd just like to thank Microbrick for sponsoring that work. They helped make that possible to get that off the ground as another port started on ESP32. They make a really cool little robot called the Edison, which is pictured there, which is a little educational robot thing. So I just wanted to say thank you to them and give them a little bit of a thank you. From there, we went on and we actually finally admitted we were doing this thing and stuck it up on GitHub, which is great because it meant other people leapt all over it. And then I went down to LinuxConf in Tassie to kind of like, launch it. Well, it's a good excuse, isn't it? We went down there, and at LinuxConf we had support from Espressif to make a little board called an IOTUS, which is this thing pictured, which has a little OLED display, and it has a little joystick, and it has an ESP32 on top, and all of that sort of stuff. And as I'm working up to my talk about how to develop C code for the ESP32, I got up on stage and said, oh, look, unfortunately, we haven't actually got MicroPython booting on the IOTUS yet. And so one in the crowd put up their hand and said, yes, I have. I went, oh, right, okay, open source. Excellent. So we did indeed get that running on the IOTUS, which was cool. And Jai, who's probably around here somewhere, got it working with the NeoPixels on the board, and people added more stuff, and suddenly we had a snowball rolling, which is brilliant. That's this community thing I'm talking about, is that we've suddenly got multiple contributors. It's not just one person or two people or three people pushing this thing along. It starts snowballing. So that's really exciting. We went from software SPI to hardware SPI, which was a great start. Other functions appeared. Someone said, why is there no PWM? And I said, of course there's PWM. And they said, no, there isn't. And I went, oh yeah, I didn't write that after all. I thought I had. Oops. So someone implemented that, which is great. Andy Valencia there. UART support arrived, so now you can talk to all 3 UARTs on the board, which is another thing that took me by surprise when I discovered I actually had 3 UARTs, which was kind of cool. And other people are adding more support all the time. I've mentioned a few names here. There are many, many, many more contributors. In the thing, GitLog is your friend. But I just wanted to emphasize the fact this is becoming a community thing. This is becoming something that is bigger than just a couple of people. And here we are at PyCon again. What's in progress? So the ESP32 also got used on a badge at a conference it's in Amsterdam, I think, or near Amsterdam anyway, called SHA. And a whole bunch of people from that community have been putting a lot of effort in it on things like Bluetooth LE, and I think the same people are involved in the deep sleep thing. I can't remember now. Those are pull request numbers. And those things are waiting to kind of get merged back into the main line of ESP32 MicroPython. But once that's working, it'll support Bluetooth LE, it'll be able to deep sleep so that you can run it off batteries and it can wake up, do some thinking, go to sleep again. There's some more sophisticated PWM control available on the chip. One of the fun things about this is that Espressif are kind of doing a lot of their development of their SDK very publicly. This is very unusual, but they've released a very early SDK. They call it an IDF, IoT Development Framework. They released it quite early with a lot of things missing. And then they're slowly adding those things bit by bit, which is a little challenging at times for us trying to keep up with their development. But it's really exciting as well, because every now and then you'll discover a new piece of hardware is now available. We also need to have at some point some support for that ultra-low power CPU, because that's a really exciting piece of hardware for anyone who wants to run stuff on batteries. And a really exciting thing that's just suddenly become a thing recently is to attach more RAM to this thing. So there's a new chip coming out from Espressif, or a new module coming out from Espressif soon, which has got 4 megabytes of onboard RAM, serial attached RAM, so it's just attached to the internal bus of the module. And I think it's really exciting. Can we make MicroPython use this big slice of RAM? You know, if we've got more RAM available, can Python use that? And I've been sort of looking at it and poking gently at it, and just before this talk, Googled it again, and someone's in the meantime implemented it. So that'll be really, that's pretty amazing. It's something we have to now look at how to integrate that back into the main line of MicroPython, so as not to make it too much of a fork. But it's really exciting that we can now address that much more RAM. And if you look at the dev kits and things like that, a lot of dev kits have a pixel map display of one sort or another. IOTUS had a display, the dev kit from Espressif has one. The badges all tend to have maybe an e-paper display. It would help a lot to have a kind of standardized frame buffer approach that would work across multiple of those devices, so that everyone doesn't have to reinvent how to do this every time. It's probably a much lighter approach than you'd normally use for like a web tech or whatever, but we can come up with something. So those are all things that are kind of in progress at the moment. So we've got coming up, we've got a sprint signed up for Monday. That's really exciting. I've never actually kind of run a sprint before or participated in a PyCon sprint, but I'm hoping it will let us achieve some really cool stuff. Espressif have very kindly provided some support for that. There's a whole box full of ESP32 dev kits for people who can contribute at the sprint. If you happen to have a sprint ticket for Monday, please do come along. It will be a hoot. I think it's not just, I mean, MicroPython itself is written in C. So you need a fair bit of C programming ability to make much progress within the guts of MicroPython. But if you do have some C background, it's actually very, very easy to work on. So partly, I guess, because it's relatively recently implemented and it's implemented in quite a modern way and it's quite well documented internally and all of that sort of stuff. And it's a nice code base to work with. But the other thing is that there's a lot of work that still needs to be done on this platform in Python. And a lot of work that needs to be, feedback that needs to be done about how do we make this a better Python platform? How do we keep our classes and our libraries as Pythonic as possible within the scope of MicroPython? So there is definitely a role for people who aren't C people as well within that sort of sprint and all of that. And it'd be great to come and hang out and just, get a chance to talk to each other about what we're interested in doing and so on and so forth. Tim, who is around here somewhere or another, up the back, Tim. Hey, Tim, has also got an FPGA board port of MicroPython that he's interested in doing some work with on Monday. That's basically running MicroPython in a little soft core within an FPGA. And so there's a whole Python tool chain there that lets you configure the FPGA from Python and then program the actual running of the FPGA in Python and so on and so forth. It's a really interesting effort. I don't think Tim's talking about it this year, but you talked about it at LinuxConf, right? Have I got my timeline right?
I'm talking about FPGA stuff, but not MicroPython on FPGA specifically.
Right. Oh, there you go. Anyway, there's a YouTube video. If I work out which one I'm talking about, I'll post that link as well. So there's that. And the other thing I wanted to just mention is I'm running or organising a MicroPython Meetup group here in Melbourne at Connected Community Hackerspace, which is just opposite Swinburne. That gives you a chance to come along and just meet up with some fellow enthusiasts and do some interesting kind of work. It's very hands-on space. There's machine tools, there's things like that. Play around with hardware, have a bit of an experiment, get to know the platform. Not so useful for those of you out of state, but for people who are around here. If people are interested in running a similar thing anywhere where you happen to be from, happy to help out with information about that stuff too and help get things started elsewhere. So cool, that's about all I had to talk about in terms of this stuff. Does anyone have any questions about the ESP32 port or about MicroPython in general? Thank you.
I'd heard that there were some issues with the actual silicon in the ESP32 in terms of some of the functionality. Is that, or maybe you could comment on, sort of just give an update in terms of where that's at?
There's Rev 1 silicon out now, so you could say that that would imply that there isn't a totally perfect thing in Rev 0 silicon. I don't know specifically myself. I haven't bumped into the problems, but then my stuff has occupied a relatively small part of the silicon, so I'm not sure. Yep.
Thank you, Nick. What's the development experience like on these chips? I know it's a GCC port, but is there a good GDB, interactive debugging, things like that?
I've been strictly off in the world of print statements and logging via the serial port.
I bet you're glad to get those UARTs working.
Yeah. So I haven't actually tried using GDB on it. Interestingly, though, the DevKit J or whatever it's called, not the DevKit C little ones, but the big ones have a JTAG port and things like that on them. So, and I think, I'm not 100% sure, but I think what's on there is, so there's a dual USB to UART converter, and one of them goes to the standard serial REPL kind of port that we use and that you flash the chip through. I think the other one actually goes through to the JTAG port or something similar like that. So there's some circuitry there that I don't yet understand that I think will let you do that debugging over USB rather than actually having to get out the old Xilinx JTAG cable or whatever you've got. So far though, I haven't bumped into too many things that aren't solvable that way. Maybe I've just been lucky.
I wanted to comment also those traces, the silicon traces look like Pythons.
Any more questions? Well then, thank you,
Cool,
Nick,
thank you.
for the wonderful